Good morning, dear students. Welcome back to physics class. In today's class, I introduce a new chapter. It is thermal properties of matter. It is the third chapter from volume 2. The discussing topics are A. Temperature and heat, and B. Thermal expansion. You might have noticed that you will feel hotter in afternoon time on bright day when you compare to a windy night. This is because of the difference in temperatures. Temperature is very high in the afternoon as compared to night. In simple terms, you can say that when temperature is more, heat is more, and when temperature is less, heat is less. From the given picture, one indicates temperature is more, it is hot bright day, and second one indicates temperature is less. It is the cold ice water taken in a glass. When substances are subjected to heat fluctuation, it is the variable heat energy. Surely they react. How do they react? It is decided by the thermal properties of the materials. The two major components of thermal properties are, first one is heat capacity and second one is thermal expansion. This chapter gives you a clear picture about this concept. Due to the transfer of heat energy, the hot cup of coffee will become cold. What are the units of heat energy? SI unit of heat energy is joule, and some of the commonly used units are calorie and kilocalorie. Let us see the relation between joule and calorie. 1 calorie is equal to 4.18 joules and 1 kilocalorie is equal to 1000 calories. It is equal to 4180 joules. What is SI unit of temperature? It is Kelvin. Some of common used units are Fahrenheit and Celsius. You know, thermometer is a device used to measure temperature of a substance. It works under the principle of expansion of fluid on heating. If mercury is used, it is called mercury thermometer. A thermometer gives the same reading despite of any gas is used, because all gases have same expansion at low temperature. What are the variables that describe the behavior of a gas? They are three variables. First one pressure, second one volume, and third one temperature. That is, they are P, V, and T. If temperature is expressed in unit of Kelvin scale, it is said to be absolute temperature. We can convert Celsius scale temperature into Kelvin scale by using the expression capital letter T is equal to small letter t plus 273.15, where capital letter T stands for Kelvin scale temperature and small letter t stands for Celsius scale temperature. Gases which have low density obey certain laws. What are these laws? They are first one Boyle's law and second one Charles law. According to Boyle's law, PV is equal to a constant when T is a constant. The product of pressure and volume of fixed mass of gas at a constant temperature is a constant. And according to Chart's law, V by T is a constant when P is constant. That is, ratio of volume of fixed mass of gas to absolute temperature is a constant when pressure P is constant. We have two gas laws. First one is PV is equal to a constant. It is Boyle's law. And second one is V by T is equal to a constant. It is Chart's law. By combining these two laws, we will get one common equation. It is PV by T is equal to a constant. This constant is represented by capital letter R. It is also called universal gas constant. Its value will be equal to 8.31 joule per mole per Kelvin. The expression PV is equal to RT is the ideal gas equation or ideal gas law, which is applicable only at low temperature. Those gas which obey this law are called ideal gas. Actually, ideal gas is not existed practically. Many of the gases whose behaviors are just approximate to the ideal gas behavior. What is the importance of studying ideal gas law? It is helpful for studying the behavior of different gases. In 5th chapter of Volume 2, there is a detailed study of ideal gas law. For any quantity of dilute gas, we have to use the modified form of ideal gas equation. It is PV is equal to nu RT, where nu be the number of moles in the sample of gas. Then, what is mole? It is one of SI units used to express the number of particles or molecules present in a substance. In this case, it shows the number of gaseous molecules. 1 mole of gaseous substance is equal to 6.023 into 10 the power of 23 number of molecules in the substance. It is also called Avogadro number. In a constant volume, temperature of gas in a thermometer varies with respect to pressure. Temperature changes linearly with increase in pressure. This variation is shown in given graph. Let's learn what is absolute zero. Absolute zero is defined as minimum absolute temperature of an ideal gas. If we plot pressure versus temperature, we will get a straight line. As shown in given graph, we extend the line backwards to the x-axis. It will intersect at the marked point minus 273.15. This value is known as absolute zero. It is the temperature of minus 273.15 degrees Celsius or 0 Kelvin. Then, what is the relation between temperature in Kelvin and in Celsius scale? It is given by Kelvin scale temperature T is equal to Celsius scale temperature Tc plus 273.15. There is another expression used to convert Fahrenheit scale of temperature into Celsius scale of temperature or vice versa. The expression is F minus 32 whole divided by 18 is equal to C by 10, where F be the Fahrenheit scale of temperature and C be the Celsius scale of temperature. This slide shows comparison of Kelvin, Celsius and Fahrenheit temperature scales. You have to notice the two marked points. They are steam point and ice point. Steam point is the upper fixed point and ice point is the lower fixed point. And also you should see the absolute zero in each scale of temperature. Now I am going to talk over the topic thermal expansion of substance. It is a common experience that when we turn on hot water tap, the water flow becomes very fast as the water is still cold. Later on, this flow will become less. Here, when hot water starts coming, the flow of water becomes less. In some cases, the flow of water may stop. Why does it happen? Did you think about it ever? This is because the hot water heats the metal valve inside the tap, which expands to block off any more flow of water. This is thermal expansion of the metal valve. Then, how can we define the thermal expansion of a substance? It is the phenomenon of increase in dimensions of a body due to increase in its temperature. What is the reason of thermal expansion of an object? When any object is heated, particles or molecules start moving in random motion, and thus average distance between the particles or molecules increases, and as a result the object appears to be expanded when it heated. In figure A, molecules are seen very tightly packed. When the object is heated, the molecules start moving apart in random motion, which can be seen in figure B. When an object is cooled, it contracts, which is referred as negative thermal expansion. You should notice that thermal expansion of solids and liquids are small as compared to the gaseous substances. Let us see what are the different types of thermal expansion. There are three types of thermal expansion. They are linear expansion, area expansion and volume expansion. First, I am going to discuss on linear expansion. Linear expansion means expansion in length due to increase in temperature. It means fractional change in length, that is, how the length is changing with respect to original length. As seen from the given figure, the length of the cylindrical object is increased from L to L plus delta L on its heating. Let delta T be the increase in temperature, then what should be the increase in length per unit length? It will be equal to delta L by L. Now it is going to calculate the coefficient of linear expansion. What is coefficient of linear expansion? It is a parameter which tells us how the size of an object changes with change in temperature. It is defined as degree of linear expansion divided by change in temperature. If this solid substance is in the form of long rod, then for small change in temperature, that is delta T, the fractional change in length, it is delta L by L, is directly proportional to delta T. Then it can be mathematically expressed as delta L by L is proportional to delta T. So delta L by L is equal to a constant into delta T. This constant is denoted by alpha L. It is the coefficient of linear expansion of the substance. This is a characteristic property of the material of the rod. It changes from one material to another material. Second one is area expansion. It is defined as expansion in area due to increase in temperature. In case of area expansion, there is increase in both lengthwise and breadthwise. As it is seen from the given figure, the area of the rectangular shaped body is increased from A to A plus delta A. Then what is increase in area per unit area? It is delta A by A. Since delta A by A is directly proportional to increase in temperature, it is mathematically expressed as delta A by A is proportional to delta T. Then delta A by A is equal to a constant into delta T. This constant is represented by alpha A. It is the coefficient of area expansion, which is defined as degree of area expansion divided by change in temperature. It is also a characteristic property of the substance. It varies from one material to another material. And last one is volume expansion. It is defined as expansion in volume due to increase in temperature. This means there is increase in length, breadth and height of a substance. As seen from the figure, the volume of the cube is increased from V to V plus delta V. There is increase in length, breadth and height. So, the expansion in volume due to increase in temperature is represented as delta V by V, which is proportional to increase in temperature. So, its mathematical form is delta V by V is equal to alpha V into delta T, where alpha V be the constant, it is the coefficient of volume expansion. It is defined as degree of volume expansion divided by increase in temperature. It is also a characteristic property of the given substance. It also varies with temperature. If we plot a graph between alpha V and temperature, then initially alpha V is a changing linearly, then it varies non-linearly at higher temperature, then it becomes constant. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.